Hi, ladies and gentlemen. We are looking at notes 3.5, which are on first differences. And question number 1 asks us to consider the relation y equals 3x minus 4. So if my relation is y equals 3x minus 4, remember the general equation of a line is y equals mx plus b. And the m represents the constant of variation. Here, my m value is going to be 3, so my constant of variation is going to be 3. Okay? And then my b value right here is my initial value, and my b value, it tells me right here, is -4. So this is my initial value. Okay, now if it asks me to complete the table of values right here, in order for me to be able to do that, I need to just randomly choose some values. So what I'm going to do is I'm just going to start at -1, and I'm just going to work my way up. So -1, 0, 1, and then 2. And those are the values that I'm going to use when I create my table of values. Again, you can just choose any values you'd like, okay? So let's go ahead and see what happens. So I know my equation is y equals 3x minus 4. So here, in this example right here, remember we have infinite points on a line. This is just 4 of our infinite points. So I'm going to figure out 4 points, connect the dots, and I'll have a line. So every time I see an x, I'm going to replace it with, here, -1. And I'm going to see what I get. So here I end up getting y equals, this ends up being -3 minus 4, so I get y equals -7. So my corresponding y value is -7, okay? Then I'm going to do this again. So let me just move this stuff out of the way right here. So we'll put this over here like that. The next one I'm going to do is y equals 3x minus 4 still, but instead of x, I'm going to replace it with 0. So it's 3 times 0 minus 4. Well, this ends up giving me 0 minus 4, so my y value is -4. Okay, we're going to do it again, but this time we're going to do it with 1. So every time I see an x, I'm going to replace it with 1. So I end up getting 3 minus 4, which is -1. Okay, and then I'm going to do it one last time. Y equals 3x minus 4, but every time I see an x, I'm going to replace it with 2. So I'm going to say 3 times 2 minus 4. So I end up getting 6 minus 4, which is 2. Okay, now you should notice that there's a pattern happening here, and we'll actually see how this pattern relates to the information we wrote down here. But if you don't have a pattern happening, then something went wrong. So question A says complete the table of values. Check, we're done with that. Okay, so now question B says to graph the relation. So in order to be able to graph this relation, I need to number my axes. So I'm going to and label it. So I'm going to label this x and y. I'm going to put numbers on my axes. So here's 0. I'm just going to put a 2, a 4, and a 6. If you want to number every single one, go for it. You don't have to. It's up to you. -6, -4, -2, -2, -4, and -6. Okay, and then I'm going to graph out my points. So my first point is -1, -7. So I'm going to go to the left 1, and I'm going to go down 7, because that's what -1, -7 means. Okay, the next point I have is 0, -4. So I'm going to go nowhere left or right, and then I'm going to go down 4. Okay, the next point I have is 1, -1. So I'm going to go to the right 1 and down 1. I'm going to put a dot there. And then the last point I have is 2, 2. Okay, once I do that, I can go ahead and connect my dots and I'll have my line. So this is what my line is going to look like. I can graph it out right here. Sorry, so here's what my line is going to look like. Now you need to make sure that you have arrows on both sides of your line. If you don't have arrows, then something is not correct, because it goes on forever on both sides of my line. So this is what my graph will look like for this equation right here. So the question now says, is the relation linear or nonlinear? The relation is definitely linear, and it still follows this y equals mx plus b format. We know that the m is 3, so we know that it's going up by 3 every time. Let's verify to make sure that it really has a slope of 3. So my rise right here is 3. It went up by 3, so this is positive 3. My run is 1, so it's 3 over 1, which is 3, which is what I want. And then my b, I want to verify that my b is really negative 4. So right here, this negative 4, it has to be on the y-axis, or I could look at it here. It's when x is 0. When x is 0, b is negative 4. So this is my b, or my initial value. It checks out for me, so this works. Okay, so we know our relation is linear. Now, part D says to calculate find the first differences. So how do I find first differences? The way I do that is I take the difference from one x value to the next x value, as well as one y value to the next y value. So let me show you exactly what I mean by that. From negative 7 to negative 4, it went up by 3. So my first difference is positive 3. From negative 4, it went up to negative 1. It also went up by 3. And from negative 1 to positive 2, it also went up by 3. Now, this needs to be consistent if this is consistent right here on the other side, as long as this is also consistent. So this right here, this goes up by 1. From 0 to 1, it goes up by 1. And from 1 to 2, it goes up by 1. And remember, our first differences right here, essentially what we're doing is we're just doing rise over run. And the rise, it's always going up by 3. The run, it's always going up by 1. So that's the first difference will tell us our slope. So what conclusion can you make about the first differences? First differences must be constant. What does the word constant mean? It means it has to be the same. So first differences must be constant in order for a relation to be linear. Essentially, you're just saying you're finding a slope because the slope is always constant, okay? So once we get that down, let's take a look at question number 2. Use first differences to determine which of these relations are linear and which are nonlinear. So let's go ahead and do the first example together. My x values are all going up by 1. From 0 to 1, 1 to 2, 2 to 3, 3 to 4, they're all going up by 1. Now my y values, to go from 7 to 3, I'm going down by 4. From 3 to negative 1, I'm also going down by 4. From 1 to negative 5, I'm going down by 4. And from negative 5 to negative 9, I'm going down by 4. Okay? So if I take a look at this right here, each time I do this, I've got negative 4 over 1, which is negative 4 every time. So this is linear because first differences are constant. Okay, so now let's take a look at the next example. This time it's going up by 2 for my x values. Okay, but my y values, it's consistent, which is good. My y values are going down by, sorry, my y values are also going up by 2 here. This is going up by 4. From 3 to 9, it's going up by 6, and from 9 to 17, it's going up by 8. So here, when I do 2 over 2, I get 1. Here, I've got 4 divided by 2. 4 divided by 2 gives me 2. These are not the same, right? We don't get the same answer here. Here, I'm going to do 6 divided by 2, which gives me 3. And lastly, over here, I'm going to do 8 divided by 2, which gives me 4. None of these answers are the same, so therefore this is nonlinear because the first differences are not constant. Okay? All right, so now let's go ahead and take a look at our last example that we have right here. So in this last example, I'm going to do the same thing. I'm going to see, well, what's my x going up by? It's going up by 3 to go from -4 to -1. To go from -1 to 2, it's also going up by 3. From 2 to 5, it's going up by 3. And from 5 to 8, it's going up by 3. Here, my x value from -10 to -5, it's going up by 5. Here, it's going up by 5. Here it's going up by 5, and from 5 to 10, it's also going up by 5. So essentially, for each one of these, I would get 5 over 3 every single time, right? It's not changing. So therefore, this is linear. Same exact reasoning. Because the first differences are constant. So essentially, we're just looking for a constant slope. If we have a constant slope, it's a linear relation. If it's not a constant slope, then it's not a linear relation. Okay? All right, see you next class.